Hi everyone! In this video we're going to talk about measures of variation that are meant to describe how spread out the data are. And we're going to start with the most basic measure of the variation, and that is range. Range for a set of data is calculated by taking the largest observation and subtracting the smallest observation. So this is basically the formula. To illustrate this and another measure of variation, I'd like to use the following example. Here I have 4 small samples, and I'm going to start by creating dot plots for each. So the first one has values 20, 23, 27, and 30. Second one has values 20, another 20, then 30 and another 30. The third one, 20, 25, another 25, and 30. And the last one has all the same values, there are 25. 4 of them. Okay, now for each of these data sets, let's calculate a range using this formula. So our range for the first set is, we need to take the largest observation and subtract the smallest. The largest is 30, the smallest is 20. So it's 30 minus 20 equals 10. I could also say that's the maximum value minus minimum value. Okay, second set, set B. What is the range? The maximum or the largest observation is 30. The smallest is 20, so I'm getting 10 again. Set C. Again, it's 30 minus 20, which is 10. And for the last one, well, they're all the same value, so I don't really have largest and smallest, so I'll just do 25 minus 25. They're both largest and smallest at the same time, so 0. And I think the word range itself is pretty intuitive. And I think you would agree that the range for this set is definitely 0. There is no spread here at all. But I want to focus on the first 3 sets and observe that while the sets look different, and that's the reason I wanted to show dot plots to visualize them, range is the same for all of them. So it's 10 units for each set. And while range tells us the difference between largest and smallest observations, so that's the way to measure the spread, we can see that it's not the best measure because obviously it's not describing what happens between the largest and the smallest observation, and these are the only 2 are involved in the calculation. So we definitely need a better way to measure the spread or variation than just using the range. Before we move on, since we already noticed that those sets look different, let's try using just our intuition to put the sets in order from the most spread to the least. Well, I think I can see which one has the least spread, right? That's D for sure, so that's going to be the last one. Which one does have the most spread? Well, if I think in terms of dots or values being further away from the center, which of course I haven't measured, I'm just going to use my intuition, then I'd say set B has the most spread because dots here, all dots are equally far from the center. So I'll say B has the most spread. Then it's A or C. Well, since C has dots, right in the middle, or 2 dots right in the middle, I would say that A is the next one as far as the spread. And then it's going to be set C, and then definitely D is the last one. So that's how I think we should put them in order from the most spread to the least spread set. And while I just did that using my intuition and just simply by observing the dots on a dot plot, we do have a good measure of variation that considers what happens with all values in the data set, not just the minimum and maximum value. And it's called standard deviation. So the standard deviation describes how far, on average, each observation is from the mean. So standard deviation is measured by just one number, but to calculate that number, we have to consider every single value in the set. And in general, the idea is that the greater the spread, the greater the standard deviation will be. So that's how that number is being used to measure the spread. And here are the formulas for calculating standard deviation. We have two formulas because one formula is for the sample standard deviation, and we denote it by lowercase s. And the way I remember is that, well, sample standard deviation is denoted by lowercase s. And we also have formula for population standard deviation. They're very similar. The only difference is in the denominator of that fraction that's inside the square root. See how it's n minus 1. By the way, remember that n is the sample size, so we have to reduce it by 1. And in the population standard deviation formula, we're dividing by n population size. So that's the only difference, basically. But as I already mentioned, the standard deviation is a good way to measure the variation because in this formula right here, x sub I, that's the place where we would input every single value from the set, from the sample or from population. So if we want to calculate standard deviation by hand, we will be using one of those two. But there's also a way to find standard deviation by using calculator. So I'm going to show you the steps, and let's apply those steps to the sets, or maybe two of the sets that we have here. Remember that we ordered those sets from the most spread to the least, and now we have a way to check if that was done correctly. So let's maybe, check sets B and A. So we're going to calculate standard deviation for set B and then for set A, and we'll compare the results. So according to the way we put them here, and the fact that greater the spread, the greater the standard deviation will be. So standard deviation for set B should be higher than standard deviation for set A, but we'll check. Okay, this is how you perform steps on the calculator. So you start by entering data into the calculator. Now I start with set A. To enter the data into the calculator, I have to press on Stat, and then I press Enter because what's highlighted here, tab added, and then item number 1 added, that's the one I need. So I press Enter. Okay, I had to rotate my camera so you could see the entire calculator. So remember we stopped here, I said that you need to press on Enter to go into that menu. Now here you're going to see a screen that looks like a table, columns, right, and rows. Well, that's where you're going to be inputting your data set. It's possible that you might have some information there from previous examples, so you definitely want to clear all that information. So what do? You use up arrow to highlight the title of the column. It's called L1 because technically they're not called columns, they're called lists. So list 1, and then I press clear and then Enter. After that, the entire list is cleared. So I can practice that again by now highlighting L2, list 2, and pressing clear again, and then Enter. So I don't really need 2 lists, I only need 1 because I only have 1 data set for now, so that's set A. And after that, I'm going to be entering the values from my set. So it's 20, I literally start typing them, and after each I press Enter. After each value, then 23, Enter, 27, Enter, and then 30, Enter. So once I entered my data set, well, I'm ready to find standard deviation. And for that, I have to press on Stat again. Then I switch to a tab that's called Calc for calculations. And here I will need item number 1, so I'm not moving anywhere. I just press Enter. And my calculator confirms what list it has to look at. Well, I entered my dataset in L1, so that looks correct. If you happen to enter your data into another list, or maybe it doesn't say L1 and you need to change it to L1, so lists are labeled here above buttons 1, 2, 3, 4, 5, 6. You can see in blue, well, in my calculator I have L1, L2, L3. So anything that I have in blue on my calculator, I will always activate using second button. So I would press, let's say, second, and then I press on 2. See how it changed it to L2. Just follow the color coding for your calculator. Now I have to go back to L1. That was just for the practice. So second, and then L1, and then 1. That changes to back to L1. Okay, so yes, my data is in L1 in list 1. I am ready to perform calculations. So I switch next line. I'll go down to calculate, so it's highlighted, and then I press enter. And that's where I find a lot of useful information. Now, we're trying to calculate standard deviation, right? So let's find it in the list. I mentioned that I'm going to treat those sets as samples. So remember, sample standard deviation, it's here, is denoted by lowercase s. Can you find it on this list? Yes, it's right here, s. And, well, what's right next to it? It's the standard deviation, so 4.3969, and so on and so forth. So the rule we're going to follow is that we're going to round to 1 additional decimal place compared to the raw data. Now, the raw data or our data set does not have any decimal places, so I have to increase it by 1, and that tells me that I have to round up to 1 decimal place. So I'm going to cut after 3, but since 9 follows 3, I have to round up. So actually 3 I will change to 4. So it's going to be 4.4. So set A, right here, that's the one I start with. It has standard deviation as equals, what did I say, 4.4. Okay, and just a few notes here. There are other useful information that we can find, such as X bar. Remember, X bar is sample mean. And also, talking about standard deviation, we can see how it says sigma here as well, 3.807. So remember, sigma is population standard deviation. And calculator also gives us that value. Well, it's just because our calculator doesn't know if we're dealing with a sample or population, so we just have to choose the appropriate standard deviation ourselves. Now let's repeat the steps for set B. So to close this window, I need to quit it. Here it says quit on my calculator. Since it's in blue, I'm going to press second and then button mode, because above it says quit. And now I can start over again. First, I have to enter that data set. Remember that with that, we have to press stat. We're staying here, so I just press enter. And I'm gonna enter my second data set, set B, also in list 1. So it means that I need to clear data. So I go up until the name of the or title of the list is highlighted. I press clear, enter, and now it's ready to be used for another set. So I have 20, 20, 30, 30. That's where I'm looking at, those numbers for set B. Okay, I entered the data set. Now let's calculate standard deviation. I press stat. I go to the right to switch to calc tab, and there I stay at item number 1. Press enter. Confirm that yes, I'm using list 1, press or go down until calculate is highlighted, and press enter. Okay, so here I find that sample standard deviation for that set is 5.77350, but again I will be rounding to 1 decimal place, so that means that I have to stop here. But I always check the digit that follows. Since it's 7, so it's 5 through 9, right? 7. It means I have to round up. So instead of 7, I will write 8, 5.8. So that was set B. So for that set, standard deviation is 5.8. So we were able to confirm that we put those sets in the right order from most spread to the least. Set B has standard deviation 5.8, and then set A has lower standard deviation. It means that it has less spread. And one last measure of variation that I'd like to mention at the end is called variance. So variance is basically square of the standard deviation. So if I square, let's say, sample standard deviation, it's going to be s squared on the left hand side. That is sample variance. And the right hand side will look very similar, but no square root. Remember, square cancels square root, so it's going to be s squared and expression that's inside. That represents variance of a set of values. Okay, so we're now familiar with three different ways to measure variation: range, standard deviation, and variance. And standard deviation is going to be the one that we're going to use the most.